So hey guys, Stinky Cash here. In today's video, we're going to talk about perspective and horizons, and I'm going to try to explain to the best of my ability why we see things like the sunset and why we see the bottoms of buildings being obscured by the horizon. So the first thing I would want to ask is, if we live on a flat plane, would there even be a horizon? And the answer to this question is absolutely yes. Of course there would be a horizon. So many of the so-called debunkers of the flat earth theory, including the guy in that video, the top 10 ways we know the earth is round, they say that on a flat plane there would be no horizon and that you would be able to see infinitely.
The simple fact is, if the Earth were flat, there wouldn't be a horizon beyond which things could disappear. So from across Lake Michigan, you'd be able to see all of Chicago, as well as the Rocky Mountains.
But this is silly nonsense. A simple Google search should be able to clear this up beyond a shadow of a doubt. So for all you non-believers out there who say there would not be a horizon on a flat plane, let's go to this website called askamathematician.com and see what they have to say. Question: if the Earth was flat, would there be a horizon? If so, what would it look like? If the Earth was flat and had infinite area, would that change the answer? Answered by a physicist. There'd definitely still be a horizon if the Earth were flat. Let's repeat that. There'd definitely still be a horizon if the Earth were flat. It would be in almost exactly the same place and look essentially identical. While the Earth isn't flat, adherents to that theory are correct in that it's nearly so. And if you're standing on the surface of a round something the size of the Earth, it's difficult to tell the difference. In fact, mathematically, you can make the argument that a flat Earth acts the same as an infinitely big Earth. So basically what they're saying is the horizon on an infinite flat plane would work the exact same way as it does on a ball with the radius of 3,959 miles. You wouldn't be able to tell the difference. It works the exact same way. So not only do we know that there would be a horizon on a flat plane, but we know the formulas to calculate the distance to the horizon on both a flat plane and a round ball. And what's interesting about these two formulas, if you plug in your height above the ground, you're going to get about the exact same distance to the horizon using both formulas. That's correct. The distance to the horizon on an infinite flat plane computes the exact same distance to the horizon on a ball with a radius of 3,960 miles. It's almost exactly the same distance to the horizon to a T. This leads me to believe that the size they claim the Earth is was reverse engineered to line up perfectly with the perspective optics of an infinite flat plane. This way you won't be able to tell the difference. So let's begin by looking at this perspective diagram. As you can see, all these horizontal parallel lines all converge at the vanishing point on the horizon as they get further away from the observer. So the lines that are below us appear to go up in the frame as they get further away, and the lines that are above us appear to go down in the frame as they get further away. This is similar to what it would look like if you were looking down a long hallway. When you look at this picture of a hallway, we know that both the walls are parallel with one another. And we know that the floor and the ceiling are also parallel with each other. But our eyes do not see them that way. Our eyes converge them all at the horizon. So this is a first-person perspective. Okay, you are the observer in this picture. But let's take a look at what this would look like from a side angle. All the horizontal lines that are visually parallel, they all visually intersect at the horizon. Okay? So it forms a right triangle here, with the horizontal line being at eye level, and the hypotenuse is the ground. It appears to go up to the vanishing point, to the horizon, which is right here. So we know that all these horizontal lines converge at the horizon, and they will radiate out of the horizon. All these radiating lines are actually parallel, but our eyes don't see them that way. So a lot of these flat earth debunkers, they make side view illustrations that show these horizontal lines parallel, like this, when they should be making their illustrations like this. The higher up the horizontal parallel line, the steeper the angle at which it converges at the horizon. Okay, so notice how we have a red solid line as the ground. You can't see through the ground. The ground is a true limit. So these radiating lines here, they stop at the ground. But in an upwards direction, all these horizontal parallel lines radiating out of the horizon, they continue to go. There's no limit in an upward direction. That's why I've continued these lines. So the higher up the parallel horizontal line, the steeper it converges at the horizon, at the vanishing point. Now also, a lot of flat earth debunkers, they try to say the sun would never set on a flat earth, and they create side view illustrations like this. And they say, look, this is the angle at which the observer would see the sun, and at no point will the sun ever fall below the ground. And they say the same things for objects on the ground that are moving further away. They say the boat will never vanish beyond the horizon. But this type of side view illustration is completely wrong. You need to converge your ceiling with your floor at eye level. So it wouldn't look like this. These horizontal lines wouldn't look like this, and you wouldn't be viewing the sun and the objects on the ground like this. What actually happens is it all converges at the horizon. So this is a much more accurate and factual side view illustration. And when Cash is looking at the sun, this is the angle in which he looks at the sun. And when he's looking at objects get further away from the ground, this is the angle in which he would look to see those objects on the ground. Okay, so most flat earth debunkers get this completely wrong. Now we know all the horizontal lines converge at the horizon, including the ground. Now I've continued the ground in this illustration so that I can make a point. Because if these lines are all converging after the horizon, let's pretend like they diverge, right? Theoretically. So I've continued the ground. Now if there was a boat sailing away from Cash, when it's closer, he's going to be looking slightly down to see it. And as it gets further away, he needs to look a little further up, and a little further up, and then a little further up. When the boat gets the same distance away from the observer as the distance to the horizon is, Cash will be looking 0 degrees, completely horizontal and parallel with the ground. He'll be looking straight ahead. Now, what if the boat gets a further distance away from the observer than the distance to the horizon? What if the boat got to here? Well, now Cash would have to look in an upwards direction to see something that we know is below him. It's not possible. It doesn't work. Now, you can only see the face of the ground up until your horizon. You can't see the face of the ground past the horizon. Okay? Cash can't see the ground from here to here, but he could see things that are above the ground for a little bit past the horizon. That's another function. The higher an object is above the ground, the further you could see it past the horizon, but you can't see the ground past the horizon. So if the boat was a little bit past the horizon, but had about 10, 20 feet of height on these sails, this is what Cash would see. Now, if the boat got even further away, Cash would have to look at an even greater upwards angle to see something that is below him. And at this point, that ship's not even possible to see. This is what Cash would see. Nothing. It's past the horizon. The horizon is a set distance away. Now, the same thing happens with the sun. Let's pretend like this top parallel horizontal line is the path of the sun. Cash is going to be looking this way, then he's going to look a little further down, and then a little further down. Now, when the sun is at the horizon right here, this is what Cash is going to see. And if the sun gets even further past the horizon, see how he has to look down to see something that we know is up? And he's being forced to look through this solid red line, which represents the ground, which is not transparent. Cash can't see through the ground. It doesn't work. This is what Cash would see. The sun will have set. This is what Cash sees as the sun sets. Now, many people say the sun should diminish in size and vanish into a tiny dot as it gets further away. But that is not how perspective works, okay? Because we know horizontal parallel lines converge at the horizon. For them to be correct, Cash's eyes would have to be at the same altitude as the sun. If this were the case, then yes, Cash would probably see the sun diminish in size into a tiny little dot until it disappeared. But obviously, we are well below the sun, so we see it go in a downward direction. Now, this video is a time lapse of the sun setting from an airplane. Being in the airplane at over 30,000 feet, this pushes our horizon back extremely far, allowing us to see a greater distance. From this altitude, it becomes more apparent that the sun does diminish in size as it gets further away until it hits the horizon, at which point it completely vanishes. This is exactly what we should expect to see. There's no reason we should expect to see the sun continue to diminish in size until it vanishes into a tiny dot. That is not how perspective works. So why do we see the bottoms of the buildings obscured by the horizon in this picture? Well, it's the same reason why we see boats vanish, and it's the same reason why we see a sunset. We know that the distance to the horizon is an actual set distance. So let's say the distance to this horizon is 3.1 miles. Now let's also say the distance to this island with the city skyline is also exactly 3.1 miles away. Well, if this were the case, because we could see the face of the ground all the way to the horizon, we'll be able to see the beginning of the shoreline of this island. But if the horizon is 3.1 miles away, what if the island was 4 miles away? Well, what's going to happen is it's going to appear to be a little smaller, but it's also going to start bottoming out because you can only see the face of the ground up until your horizon. You can't see the ground past your horizon. So now let's say the island was 4.5 miles away. What would happen? Well, it would continue to look smaller, but it would also bottom out. And as the island was further away from you, it would bottom out until all you could see are the tops of the buildings, and eventually you won't be able to see anything. Now, if you were to zoom in on a horizon, you're not going to be able to see the ground any further past your horizon. All you're going to do is magnify the things that you could already see to make them appear bigger and clearer. So I'll repeat, zooming in with a camera or zooming in with binoculars or a telescope does not allow you to see further in a horizontal parallel direction with the ground. All you'll be doing is zooming in on your already existing horizon, making things bigger and making things clearer. It does not allow you to see further. Now, this kind of obstruction would happen on a ball and a flat plane, but there would be one big difference. On a ball, the further away the observer was, the more these buildings would appear to be leaning over, because your local location on Earth is always on top of the ball. You always feel upright. So if the observer was, say, 50 miles away from these buildings, the buildings are going to have a slight tilt to them. They're not going to appear vertical and parallel. That's the big difference between perspective on a ball and perspective on a plane. We never see these buildings tilting over. We never see a boat tilt over. We just see them bottom out, but they remain completely vertical. The only other real difference between perspective on a ball and perspective on a plane is that on a ball, the higher up you go, the further down you would have to look to see your horizon. The horizon would fall, or it would appear to fall, as you went up. On an infinite flat plane, however, the horizon is always going to remain at your eye level. And in reality, we know that the horizon always remains at eye level. So reality matches up with the perspective optics of a flat plane, and it does not match up with the perspective optics of a round ball. So as you can see, these objects in the distance aren't leaned over, they're not slanted, they're just obscured by the horizon because they're a further distance away than the horizon is, so they appear to bottom out. They're not leaning over. Okay, so as we zoom out, guess what? We have the same horizon. Zooming in didn't allow us to see further. All it did was magnify things and make them clearer to see. Things we could technically see with our human eye if our eyes were good enough to see that far. Learning perspective really is the most important thing to realize you live on a flat plane. So many of my commenters and so many of my globe earth defenders, they don't understand perspective. They all think they do, but they don't. They understand size perspective, that objects appear to get smaller as they get further away, but they don't understand horizons at all. So many of my commenters actually say that there would not be a horizon on a flat plane. Once you say that, the argument is over. They don't teach you perspective in schools. The only people that learn perspective are artists and like architects. They don't teach this to the common person. Why do you think that is? They don't want you to understand how your senses work. They want to keep you as dumbed down and as uninformed as humanly possible. This makes it easier to control you. They want you to deny your own senses, deny all common sense, and then put your faith in them. Trust them. Trust the experts. They know better. They're smarter than you. You're dumb. They're smart. Trust them. The Matrix relies on this type of thinking. They don't want people to be able to critically think for themselves. So that's the end of my video. I hope you learned something. I hope you changed your perspective on the flat earth subject. If you found this video informative, please give me a thumbs up and subscribe to my channel. And stay tuned for some more flat earth videos. But in the meantime, this is Stinky Cash saying, keep it flat.